All right, I think clock has struck 12. Um, San Francisco, I see Donnell's joining. Thanks for joining us here on Friday in a snowy winter Friday for us up in New Haven. We got about 8 inches of snow, so we all had to dig ourselves out to get in here today. Really exciting demonstration that we have for you. As you can see here, I'm here in our factory in New Haven, Connecticut, where we build the OverWatch direct inline pumping system, where we completely fabricate it and test it here on this test tank behind me. This is the demo loop that you saw in WEFTEC, just now set up here in our lab, so we can show you its functionality. We are going to be shredding things today, so I wanted to to do that for everyone. We weren't able to do that at WEFTEC due to the water changeouts that would be needed. We have a pretty small loop here. We don't have a bunch of water. I think there's like 30 gallons of water in here. So it doesn't look pretty. And obviously we want this thing to present well at WEFTEC. So, most of these things we couldn't shred there. So we're going to be shredding here today. So you guys will get to see that, ask a bunch of questions. I'm going to start off with a presentation. It's going to be about a 20-minute presentation, talk about some of the things that we didn't really get to talk about with you at WEFTEC because things were so short. So I'm going to go ahead and start there. Amanda, you can see the presentation okay?
Yep, we can see it all good. Thank you.
All right, awesome. So, yes, just make sure you get my clicker to work. All right, so what does the OverWatch direct inline pump do for us in a wastewater environment? We are going to eliminate issues that you commonly deal with fats, oils, greases, and wipes. I can't show you fats, oils, and greases today. I didn't cook bacon for my kids this morning, so I don't have a bunch of bacon grease, but I did steal a whole bunch of wipes. I got 120 wipes that we're going to run through this thing. So you'll get to see how this thing manages a fibrous material like that. Eliminate environmental and safety risks. This thing removes a wet well, which is the dangerous environment that the associates have to work around. The odor that comes from those environments, the cleanup and the maintenance with the pumps is a mess, and this eliminates all that concern. The exposure to dangerous odors, gases. Obviously, with this system, as you saw in WEFTEC, all the influent is contained in the systems all times, never become an atmospheric. So we eliminate all those concerns. Odor compression systems, odor compressants are gone forever. Complaints in the community about odor coming from a particular wet station is gone forever. And all the maintenance that's associated with those wet wells of the vac trucks, gone forever. Eroding, corroding, discharge, suction piping within the wet well, floats hanging up, all that is gone forever with the system. And you saw the system at WEFTEC sitting on a pretty stage. It doesn't always sit in a pretty stage. I'm going to show you some pictures of it installed out in the wild. This one is what we call our package lift station. So if you wanted the direct inline pump brought into within a stainless steel basin, dropped right in the hole, hook up the inlet and discharge and power, and it's ready to go. We can provide that as well. But so I wanted to tell a little story about the success of this technology and what it's provided for one particular customer. And this one was done in Austin, Texas. There was a large residential building down there called the Sky House on a really popular street in Austin. It's a high-end residential building, 23 stories tall, 320 units. It has a restaurant on the bottom floor and as well as a grocery store. So they were dealing with constant clogging issues. I think it was 6 times in 8 weeks, they had to go to the lift station to clear out a clog. They had been dealing with a lot of grease issues because of the restaurant tied to them, and then obviously all the flushables you get in the community, or within that building, they call it community. And then you get the Texas heat involved. right? And that's when the odors started really becoming a problem for this community, for this town. Oh, there we go. The problem: 6 emergency pump clogs in 2 months. Wipes, diapers, you name it, were found in this. It's a residential building. Talked about the restaurant and grocery store causing fog buildup. Bringing in the vac truck commonly to clean out the lift station. You can see what the mess looks like in there prior to putting in the OverWatch. I love the picture there in the bottom. That's the poor building manager looking down at what he had and just saying, "Oh my gosh, this thing is a nightmare." From his perspective, he just wants to worry about getting maintenance off his platter so he can worry about taking care of the residents. This is an environment that he's not familiar with, right? And so unloading this problem, getting this, black hole of a money pit out of his space and moving it to a technology that's solves his problems was really his major concern. So the OverWatch, it is unique in the way that we are a smart direct inline pumping system. We're going to lift influent directly from the point of entry. We don't care where that point of entry is, right? So that sky house picture we showed you, 8 feet below ground is that suction location. The demo unit I'm going to show you, it's sitting on a pallet in a factory. Again, we don't care where that elevation height is. We just need 24 inches below it to install our system. We're going to simplify maintenance, eliminate the root cause of most issues we deal with, and that is the wet well. And then we do some flow matching and detection of clogs. So talk about more in detail, but that is really the key to the success here is the direct inline pumping, managing that flow rate as it comes into the system, identifying when we're having some sort of clog or blockage issue, and removing it before it really becomes a problem. So the OverWatch provides lower maintenance, right? There is no downtime for clogged pumps. You have 2 pumps on a common shared manifold. One pump is sized for 100% the capacity. The other one is there for redundancy, right? So one pump, while it's managing the flow, you do have a backup there. If one goes into a clog phase, there's the other one to help out. There is no regular cleaning of the wet well because we talked about it. We got rid of the wet well, right? No more vac trucks, no more clearing out the solidification layers, no more issues with floats. All that is removed. The complete system, all the wetted parts, I should say, are 304L stainless steel. Don't have to worry about erosion, corrosion. We do also make this in a 316L assembly. So if you're looking at this for a high acidic, high caustic environment, food and beverage, pharmaceutical, things of that nature, we can also tailor this to that too. So this is not only a municipal application. We also have many installations in industrial, and the big one in the back, if you guys want to see it, that is actually going to an industrial or organic dairy processor. Remote monitoring capabilities we can provide that with the system. So we can provide it as simple as just closing a dry contact, signaling a light, a beacon. It is scatter ready and backnet ready. And if you wanted our full homegrown system, you want to be able to take control of the unit from your cell phone, from your laptop, from your computer, trend data. We can provide that as well if you don't have those capabilities from your current system. Safer working conditions, right? So there is no buildup of odor. I mentioned all the influent is constantly contained in the system at all times, so we never allowing that to become atmospheric. No exposure to the harmful gases like methane, hydrogen sulfide, because that is completely removed from this space. And then environmental improvements, right? So there is no corrosion of the system. We use all stainless steel parts, so we don't have to worry about erosion. You don't have to worry about the corroding of the basin, whether it be concrete or some other material that H2S gas would eat up over time, right? And then you have to worry about the basin leaching. We don't have to worry about that because we've got rid of the wet well. Again, no odor pollution, odor compression systems are gone. Grit and trash removal, we're going to show you how that manages it differently, right? So we use vortex impellers in this system. So the intent is we want to pass, right? We want to pass solids. And then when we identify that the solid is not passable, we want to remove it by shredding. So different from a grinder technology where a grinder is always grinding. Grinding works well when the blades are sharp. Grinding doesn't work well when the blades are dull. This particular technology says, let's pass, pass, pass. If we come to something that we cannot pass, that's when we're going to take action and do some removal of it. The system installs in a much smaller footprint, as you'll be able to see, or as you saw in WEFTEC. The unit that we had there, capable of 350 gallons a minute, about 40 feet ahead, set right on a 48 by 48 pallet, right? So we're reducing the excavation depth, we're reducing the footprint that's needed for the installation, so making it much less expensive from a construction aspect. And then fats, oils, and grease and wipes accumulation. Again, we're going to show you that handled differently, right? Fats, oils, and greases never have a chance to separate in the wet well. No more floatable layers that takes and holds the fibrous material in it. We're going to handle those solids or fog as soon as it comes to the station, and we're going to immediately eject it so we don't get no accumulation. So the system, as I mentioned, it is a 2 pumps on a common shared body. In this picture you see here, the inlet liquid or the influent is coming from the right-hand side through a wall plate. So if you're talking about a wall flange, we're using an existing basin where you have a pipe that sits back in the basin. We can provide your wall flange to bolt right up to that basin wall, and then you can mount the OverWatch right to that. Liquid flows down the swan neck. You're going to come to a liquid level transducer, and I'll point that out on the real system when we go turn on the camera and go live. That is our floats, right? What we're doing is we're measuring liquid pressure above that point at all times and setting parameters of how we want the system to operate based on that liquid elevation. So quite simply, low pressure off, high pressure on. Dead of the night, not many people are flushing toilets, washing dishes, washing clothes, low flows. The system is going to sense that, right? It's going to say, I don't have a lot of don't have a lot of fluid in my collection network. I'm going to turn off and I'm going to wait for the next surge to come. 7 o'clock rolls around. People start showering, flushing toilets. Liquid starts to back up in the invert. We sense that higher pressure. We then turn the system on. The system runs between 2 algorithms. It runs between a linear mode, just searching for that low level off and high level on. And then it also does a PID algorithm where it says, can I pick a very, very low frequency and keep the liquid moving through the system, right? So if the system can say, I can run at 23 hertz opposed to all out 60 hertz and keep the liquid moving, keep overcoming the head pressure, it's going to do that. If it can't do it, it's going to shut down and wait for the next surge to come. And if it can do it, and if it needs to go to 23, 25, 32, 42 hertz to keep up with the liquid flow, that's what it's going to do. The body is stainless steel. I mentioned all wetted parts is stainless steel. We do have isolation valves on each side for maintenance. So if you need to remove the one pump on one side, you just crank down that wheel, close off liquid flow to that environment. The other pump can still operate while you're doing R&R on the one side of the pump. The motors are IP67 TEFC cooled motors. This is the key difference between us and submersibles, besides all the other things I mentioned, right? Submersibles are defined by the number of starts and stops because they use the pump liquid to keep them cool. We don't. We use ambient air to keep us cool. So we are not defined by the number of starts and stops. We're going to use that ambient air to keep us cool and the fan on top of the motor to keep us cool. They are immersible IP67 motors, so they do have the ability to become submerged and still operate. Not intended, we build this environment to always be clean and dry, so they're not intended to operate under a submerged environment. But if we know things happen, hatches left open, water comes from other areas, then the suction pipe, the pump still needs to be able to operate, and that's where IP67 comes into play. So how does the system work? One pump manages the flow, the other one is a standby. Liquid comes into the invert through the branch, out and around the pump and out to the discharge. What I put up on the right-hand side there is our dip cut impeller. It's a patented conical vortex variable vane impeller. It is unique in the sense that we use 100% of the efficiency of the peller to pumping when pumping, and then when we go to shredding, we use 100% of that efficiency to shredding. How do we know when to go into shred, right? We are constantly measuring two things in the system at all times. One is that flow rate, right, through that liquid pressure transducer. So we're setting in parameters and we're trending flow rate so we know how we want the pump to operate. The second thing we're constantly measuring is torque. We base that torque over that same flow rate, and we know what torque we should feel in the motors when we're operating. If we get a torque in that bandwidth or above that our bandwidth for normal operation, we're going to assume that something is starting to develop in the system, right? Maybe wipes are starting to come together. Maybe we hit a big slug of something, and the system says, okay, I need to stop and turn myself around and remove that clog. Now watch the impeller on the right-hand side. Vanes fold down, expose knives on the backside of those impellers. So as that pump says, oh, I'm going to turn around and remove whatever in there, I'm going to shred apart whatever in that volute. And while that is going on, liquid is flowing through the secondary pump. The pump that was standby has now become the online pump. And the online pump is managing the flow. The system can also detect when we're getting some peak flow scenarios. So that liquid level sensor, right? We set in parameters of how we want the first pump to operate. If we know that the motor is running 60 hertz and the liquid level is still increasing, then we know that we need to turn on the second pump. So a second pump comes on, manages the flow, and now we have two pumps managing the suction, the flow rate coming into the invert. So let's go back to that the story there at the Sky House Rainy. The installation started at 9 a.m. in the morning. We had to remove the existing pump rails, and we had to pressure wash the basin. So you see that going in time lapse here. The OverWatch was placed in the basin by 9:30. So an hour and a half it took the team there to disassemble the system and get it cleaned up. The OverWatch comes already pre-assembled. All they needed to do was install that the special flange that they needed to attach to their 10-inch HDPE pipe. They installed that and dropped the system in by 10:30. We were completely done by 6:30 with the unit. So we started off with a nasty mess, and by 6:30 we had the system up and running. So just within 1 day's time, 1 work day's time, we're able to completely retrofit, and I'll show you a picture here. Completely retrofit that basin. A little bit more about the controls. So each system comes complete with controls, 2 VFDs to control the pumps. We are not only a pump builder here, but we are a UL 508 control panel shop. So we build all of our control panels. Gives you a tremendous amount of flexibility for custom controls, right? If you need a NEMA Type 4 controller, you need a certain backnet module, you need air conditioning because of a high environment, whatever it is you need, we have the ability to fulfill that for you. And then talking about the installation advantages of this thing, because we lift influid directly from the invert, you can save excavation depths in new installations with this system. You don't have to dig as deep. If you're worried about groundwater or worried about bedrock, this is a way to reduce those issues. You see the OverWatch system on the left-hand side versus the traditional submersible system on the right-hand side. We're typically saving, at minimum 6 to 8 feet of excavation depth because we don't have that retention storage needed to keep the pumps cool. The other thing we do is because this is a dry environment and odorless environment, we can put valves and flow meters within this space. So you don't have to have a secondary valve vault anymore. So high rent districts trying to conserve green space, this is a premier technology for that. So kind of the value creation walk for this, reduced excavation depth. We only need 23 inches below the lowest invert. There is no additional valve vault meters boxes needed. Less static head to overcome from that initial lift because we don't sit as low as your traditional submersible pumps. We're VFD controlled. We use premium efficiency motors. Less space required. And no additional auxiliary systems, no more odor compression systems, no more grinders needed beforehand. It becomes quite a savings over traditional systems, taking all that consideration. So Here's a picture of the happy ending down in Sky House. So again, the picture on the left is 9:30 in the morning. Picture on the right is 6 or 6:30 in the afternoon. The same lift station, now completely retrofitted, completely clean, completely dry and odorless. It was completely installed in September, late September, and they have not had a single clogging event when they were getting them about every other week prior. So, and haven't gone through the hot Texas summer yet, but we know they're not going to have any issues with odor. So a big success there for those folks, and we do have a reference list of all of our installations here in the U.S. There's over 2,000 of them worldwide, 73 of them here in the U.S. We do have references that if you wanted to call and talk to them about their experiences with the OverWatch, we'll be happy to share that with you. And again, just some before and after pictures. Not only are we replacing traditional submersible pump systems, but pneumatic ejectors, above ground tanks with centrifugal pumps. This is a concept that can be used in a lot of different places. So besides that Sky House installation, relatively new, haven't completely gone through the whole cost savings analysis with them yet, but we've done it with some other installations. Another one being Shimmer, New York. It's a small community outside of Lake Chautauqua in the western part of New York. They had 6 hours of maintenance time devoted to their lift station each and every year. And so they installed the technology in January of 2018. To date, the total maintenance time that they've spent on the technology is 20 minutes. So 6 hours has gone to 5 minutes of maintenance time devoted to this technology. So, and that's been running 4 years now. And if you're a treatment plant operator subscriber, February, I'm being told the article will come out on that technology there. So make sure you read it. I mentioned 2,000 units installed globally, 17 different countries here in the U.S. We're making a really solid push, doing well over the last couple of years, and we've installed in some names that you'll recognize. This is the most used technology over in France by Veolia and Suez, so it's a preferred technology. And then these systems go large. The one I'm going to show you today is relatively small, 300 gallons a minute, 40 feet ahead, but we do go very, very big, up to 10,000 gallons a minute, 200 horsepower, and almost 400 feet ahead. So any questions on the technology before I turn this camera on and shred?
Hi, James. So John asked, if flows continue to increase, the second pump comes on. Do you typically design the system so that peak daily flows require 2 pumps? What happens during maintenance periods? What if one pump is down for extended periods for a full replacement? And what is the process to replace the pressure transducer? But that's a second question, sorry.
Okay, no problem. Yeah, so great question. So we do size one side of the pump for 100% of the peak flow scenario, right? So we want to make sure that one pump is capable of managing that event. I guess typically you would size it very similar to how you would for a submersible system, right? A two pump submersible system, where you have one that is responsible for the daily flow rate, the peak rate, and then you have one that is in the environment for a catastrophic event or a failure in one of the systems. So nothing really changes from that perspective when designing these pumps. As far as when you're out for a period of time, so one pump obviously should be able to manage the flow. You're just going to have to do a risk evaluation of how long you're going to be out replacing the motor for versus how long that one pump is going to run. We've done change outs. I mean, you see, we did a whole change out there in one day. You know, if there's a spare motor available, I mean, a motor change out can be done in about an hour, even in a very large system, about an hour. So hopefully the risk portfolio is pretty low for that. And then let me go ahead and turn on the camera, and I will show you how to change the pressure transducer as we go through the system. So you guys can see my camera now. Amanda, give me a yup.
Yep, we can see.
All right, cool. So again, here's our loop. I'm going to describe what you're seeing here. Again, so this is back over here is the tank. I got about 30 gallons of water here. This valve, right after the tank, is my flow control valve. Right now, I don't know if you can hear. Let me get my earphones over. You can hear the control panel is on. The pump is on. The pump is ready. It's not pumping because we don't have any flow rate coming to it. I control that flow rate here with this valve. So what I'm going to go ahead and do is, as I'm talking, I'm going to go ahead and crack it open because it's going to be in linear mode right now because it's turned off. It's going to sense the liquid pressure coming into the system. And if it can get to a point where it can regulate and pick a really low frequency, it's going to do that. It'll take it a couple times, maybe 3 or 4 times to understand what flow rate is coming in. The system is not going to start until I get to the predefined height here. So it's about 20 inches. The system is going to go ahead and turn on right about meow. Going to turn it. There we go. The system is turned on, and now we're pumping. When it gets down to that low rate, it will turn off unless it's able to understand the frequency right away. And I have been running it today, so it may get it pretty quickly. So here, so this would be my gravity invert below ground. We have it here above ground, just so you can obviously see everything that's going through this clear pipe. Here would be the wall flange. Here's my main isolation valve. Down here in the swan neck of the stainless steel body, right here is the liquid level transducer. And these are my isolation valves for each side of the motor. You can see there's 2 of them for each pump. The pump is now turned off, so we hit our low level. You'll see the liquid start to fill back up. It wasn't able to regulate it on this first one. It's going to now try a lower frequency than it did the last time and see if it's able to regulate that flow now. So going back to the question about how do we change out this liquid level sensor. So what we'd have to do is we'd have to close this main isolation valve right here, close both these isolation valves for the motors. Down here in the bottom is a stone trap clean out and a ball valve. So I'm going to do is open up that ball valve. I'm just going to dewater this part of the pump, right? So I don't know, there's 3 gallons or whatever in this section of the pump. And now I can freely remove this level sensor and replace it, repair it, clean it, whatever it is you need to do. So while I was talking, it filled back up and started running again. You can see I got a very, very low flow here. It's not even a quarter of pipe. It did just turn off there. Again, wasn't able to regulate it. It's running that algorithm to see if it's able to understand the flow rate that's coming in here. So going back to the pumps come back together in a common flapper box. I have a swing check here, and then this is my discharge. It goes back to the tank. So I'm just recirculating this water. This ball valve that I have right here, I'm using to simulate a head. So obviously we don't have much head here with this system, so I'm restricting the flow rate coming back to the system so I can simulate head. The control panel, you know, has VFDs. This is the one that we had at WEFTEC. So you can see standard, it comes with the VFD keypads right here in the front, and then you also have the HMI option if you need to. So let's go ahead and do some shredding. I got a couple things here. You guys saw lacrosse balls. I was going to show you lacrosse balls again because lacrosse balls are fun. This pump right here can pass a 3-inch solid. Crossball's like a little over 2.5 inches. So you'll be able to see this go through. One of the reasons why I like using lacrosse balls is, one, they're very hard, very solid, they're colorful, and you'll be able to hear it banging around in the in the volute. So that's one of the things here, right? So you'll hear that the ball comes down the invert. You'll hear it go into the loop. You'll hear it move around, because with a vortex impeller, we get that cyclonic effect. So you get a tornado. So the ball is in there going around and going around and going around until it can find its exit through the discharge and out. I also have, and you guys are at WEFTEC, remember these guys, are chickens. We're going to shred a chicken. I got a couple chickens. And then I also have, I have wipes. I got, how many wipes are in each one of these? I got 60. So I got 120 wipes here. We're going to shred and show you. So let me go back. It looks like the system is pretty close to regulating. I'm running at 40, looks like 44 hertz right now. So obviously just one pump, and we are regulating right at 9 inches. So I had the regulating point here 9 inches. I have it turning off at like 6 inches, and then it turns on at like 20 or 25 inches. So here, I'm going to just open up this, get a little bit more water in here, so the wipes actually head down. Again, so lacrosse balls, I'll throw in 2 of them here. They're nice and colorful. You see them go in. You'll hear them clinking around in the pump. And let's see, there's the green one came up. I think the pink one is still running around in there. It might have actually came through. Let me just go ahead and this ball valve here that I put head on doesn't allow the balls through. So there goes the green ball. You can see the pink one hasn't come up yet, but it will. So you see solids, no problem for this thing to pass. The pink one, obviously, we're still pumping. We're still running. We're running 47 hertz now, so it's running a little bit faster. You still have the pump in there. We have more flow coming in here. Let's go ahead and shred a chicken. So bye, buddy. There goes the chicken down. I might need to let the water down a little bit. It looks like he's stuck on our little coupling there. He's like, no, not me. There he goes. Bye-bye. And, oh, he got stuck on the next coupling. Oh, there he goes. I can see him. Looks like he's still hanging out there. We'll see yellow parts come through here very shortly. And then wipes here. Sorry, the water's not too clean. But let me show you how wipes go into the system and come right back out. So again, the chicken has haven't seen any yellow particles come through just yet. He's rubber, obviously, so he floats a little bit in there. Oh, I heard a squeak. I think he's in there now. Oh, no, he's not. All right, so I cut down the flow a little bit, trying to get the chicken to stop floating, so he'd go in there. So go ahead and crank. So again, I'm just changing the flow rate just so I can mess with the smaller invert here. If you get the normal course of the day, right, you're going to get these constant changing of flow rates. The system is going to go down to a point where it's not going to run, or it's going to turn off because of a very low flow scenario. I have just a 30 gallons of liquid here, so I have very little that I can control, and plus I get a fairly consistent flow rate here by my ball valve. So whatever the flow rate is what it is. So let me show you how this thing manages wipes. I'll push the here we got some wipes. So the idea, right, with the system is that because we're using direct inline pumping, we're not getting a big glob of wipes. We're going to take wipes as they come, right? One rag moving through the system. Now I got 2 rags coming into the system. Right, going in, whoop, man, right down there, you go fast. But let's just say you get a big slug of them. I don't know, maybe 57 of them. Let's see what 57 look like. There's a big slug of rags going through there. There's some more. Here we're going into a cleaning phase. You can see this thing starting to shake up a little bit. Here goes some rags through there. So the system itself is starting to slow down. We're clogging, we're managing okay, so now we've gone in reverse. The system says, okay, I've hit my high torque rate. I'm in a shredding mode now. You can hear me ripping apart things that are in there. Hopefully you can hear it from my microphone. It's going reverse. I have it set to go for 20 seconds in reverse at a high frequency. So we're ripping apart what's ever in there. If I could show you over here. Oh, it looks like it might be turning around. I'm gonna come over here so you guys can get a closer look. We are ripping apart what's ever in there. Right now, you'll see a yellow light come onto the screen when we're clogging, going in reverse. Right now we're going in the forward direction. I see the pink ball has come through. The pink ball's up here. So the pink ball came through. I see some little teeny bits of yellow from our friendly little chicken. And I'll go ahead and let that ball on through. And we're still ripping apart what's in there. So ripping apart, 60 rags when we got 2 rubber chickens in there, and it's continuing to pump, right? We're running 57 hertz now, and liquid is still flowing right through the system. Now, do I got any questions from anybody on the technology?
Their question was if we have any installations in Maryland or Delaware. I told them that we can send the U.S. installations, but you can also go to our website and we have a bunch of case studies on OverWatch for different types of installations if you wanted to see any of those. Our website's www.flowsolutions.com.
Yeah,
do you want to speak to any of the installations?
Yeah, so Maryland is one of our kind of hotbeds for all the installations. We have 10 of them in the EPA building right in the Washington D.C. We have the FDIC building. We have a couple going into some of the hospitals there. Is Walter Reed one of them? We have one out at Washington Dallas Airport. So we have a bunch in D.C. So or just in Greater Maryland. So we have a bunch that you can view. Our distributor there, Ames Incorporated, does almost a monthly demonstration at the Ritz-Carlton in the Baltimore Inner Harbor. So if you'd like to attend one of those events and get to see these again live and in the wild, feel free to give us a shout, and you can go check out that one.
So another question I have is there a way to clean the pump without getting into the pump station?
Yeah, so I guess I could have showed you here, but on here, if you just want to unclog, I can manually unclog the system while I'm here at the control panel, right? So if it's not clearing on its own, and you just want to do like a manual clean every couple weeks or something, just because it makes you feel good, you can just come over here, put it in hand mode, and then have it unclogged. So and it will rip apart what's ever in there. But again, there's no cleaning of the wet well itself, so you don't have to go down and clean out the environment.
Can we see the pump run all out? Or does that not work when it's spreading?
Yeah, I could probably set it up to run all out, but I'll probably since I don't have I have my sock, I have my filter sock on the discharge tube to catch all the water, so don't put it back in the system. I'll probably blow that thing right off. I don't know what would happen, so I'm probably not going to do that.
Okay. So another question I got was, our process utilizes cleaning agents. What steps can be taken to confirm long-lasting performance?
Yeah, so this actually is very helpful if you have cleaning agents from like a SIP process, right? So if you're doing wash down of facilities, what's great about this technology is we're not holding a lot of liquid uh, in that environment that's going to agitate or degrade, all the elastomers in a traditional system. So those, just like fats, oils, and greases, just like wipes, those cleaning solutions are going to come into the poop, into the pump, and out to the discharge. And depending on the cleaning agents that you're using, you may have to just go through a quick wash cycle just to remove that small little volume of water through the pump, depending on the elastomers that we use. But again, we make this thing in 316 with Teflon elastomers, so we can manage some pretty nasty stuff.
Next question. If something large is trapped in the inlet, how do you remove it? Do you need to pull the entire system off after the isolation valve? In any installations, has there been an instance where something couldn't pass, and how was it addressed?
Yeah, so let me take you over here. Camera down. I don't know if you guys can see.
Yep, we can see it.
You can see the bottom side here. Okay. So any large particles that come into this environment. So what's nice is this branch valve here is sized for a 3-inch passable. This is a 6-inch inlet. So anything that is smaller than 3 inches will come up into the pump and be shredded. Anything that's larger than that is going to sit down in the stone trap cleanout. So I don't know if you can see this down here in the bottom. Here's a little handle. I have this little pipe on here out of the ball valve. What you would want to do is if a large particle came into the network that was too big to go up to the pump, right? So if we're talking like a large brick, large stone, piece of wood, things of that nature, it's never going to get to the pump. So it's never going to damage the impeller or damage the pump, stop it in its tracks. It's going to sit safely down in this environment. So this would be one of the maintenance intervals that we would recommend for folks is when you get this thing installed, maybe in the first month, you go in, you just shut these two isolation valves down, shut this main valve down, dewater this section of pump, remove the stone trap clean out. Now you can access the large particles that are in there, measure the amount that's in there, know how much you accumulate over over that period of time, and then adjust your maintenance intervals around that around the amount that you find in there.
All right, so have you successfully retrofitted a pneumatic ejector station?
Yeah, so the whole EPA, all 10 of those were pneumatic ejectors. We did one in the town of Wyckoff, New Jersey. We've done 2 in the SEPTA organization, Southeastern Pennsylvania Transit Authority. These are really, really great for pneumatic ejector replacements because they kind of work the same way, right? Dry pits. This can run in a linear mode, just kind of the same way the pot is. The pot waits to fill up, hits a certain level of volume in there, shoots it out. This thing is going to operate the same way. If you send me an email, I can send you the case studies, all the pictures, things of that nature, or you can easily go on our website, look up case studies, look up the one on, I don't know if we called it Wyckoff. I think we called it like New Jersey pneumatic ejector replacement or something like that. It has the case study in there and some pictures, the before and after. So this would be great for that.
Any spare part recommendations, and what's the lead time for motors or other major replacement items?
Yeah, so what's really cool about the system is there's not a lot of maintenanceable parts. Um, so this motor assembly sits on this motor mounting plate. I guess I'm saying this, and I'm not sure if you guys can see. Okay. So here, this motor mount assembly sits on this motor mounting part, and the impeller is actually close coupled to the shaft right on the underside of this impeller. So when you need to remove anything, this right here, I'm just going to remove these 8 bolts along the bottom, and this whole assembly comes off the top, and now everything is there to be maintenance. You know, if you wanted to have spare parts, I would probably recommend, you know, a spare motor. Motor should last a very long time, but you know what? If it goes down, you're going to need the motor. Mechanical seals fail over time in all pumps. Mechanical seal would be good to have. The pressure transducer would probably also be something to have on the shelf. Of the impellers, you know, if you have a sandy, gritty environment that would rip apart an impeller over time, you probably want to have one in the long term. I don't know if it's really a short term thing needed, but other than that, there's really not many items that you need to maintenance or keep on the shelf. So it's great. You know, we're located in New Haven, Connecticut. It is our one and only facility. We do stock motors and all the critical spare parts for this here in our facility. So depending on your location would depend on how quickly you can get some parts from us. Oh, I also mentioned that on the control panel, probably you also want to have some spare fuses on the shelf. But other than that, the VFDs, obviously, you guys know the experience with VFDs, they last a very long time. So yeah, shouldn't be a lot of things.
The last question I have is, we see a high percentage of pump failures and maintenance due to fog. How does the system help combat all of those fogs?
Yeah, so good question. You know, what's great about this technology is that we direct inline pump. We don't have an opportunity for things to separate, coagulate. Fats, oils, and greases that come into the system are going to be immediately ejected and not collect, and not going to stick on basin walls and cake up. It's going to come into the system and immediately go out. So this is, if you have high levels of fats, oils, and greases, this is really the technology that should be used for the environment. Well, if that's the last question, I do want to thank everyone for coming to join us on Friday, this Friday. If you have any questions, you know, you can feel free to reach out to me. I think you all got the email invite from me, so feel free to send an email back to me if any questions come up later on. If you have a project that you're working on that you'd like to look at this system, again, all I need is a flow rate, head, and then the power needs you have, and we can spec out a system for you to manage that. So yeah, look forward to hearing from you guys, and check out our YouTube channel. There's a bunch of great videos on there of installations, the WEFTEC demo, some demos that we've done just like this are posted out online for you guys to view. And then obviously connect with me on LinkedIn as well. So you know, love to chat with you there. I try to post some cool things about the technology every now and then, new installations, things of that way. So find me on LinkedIn, and everyone have a fantastic weekend.
Thanks, team.